Hey everyone, welcome to the walkthrough video for chapter project 4.8. So what we want to do is first just show how we can navigate to get to the chapter project. So in MOM, if we scroll down into module 2 past all of our lectures, there's going to be a section for chapter project 4.8. And so the first thing you'll see is resources. So these are some videos that I've linked to kind of refresh on any information that we need in order to successfully complete the project. The next part, you're going to have a link to this video. These are the directions. And then you're also going to be able to download this document. So when you click on this link, be able to download this document and save it. So if I want to save to the desktop, I'd probably like to use my name on this one. So there's my template. And then the last part of this little section here is where I'm going to submit it. And we'll get to that in 1 second. So when I open up my template, you may have to click enable editing. So what you want to do here is you want to fill out your name. So anywhere that's highlighted in green, these tend to be things that are more embedded in the text. So I wanted to bring your attention that you should be filling those out. And then we also have a few tables and things like that. So the table, hopefully it's clear that you want to fill that out. So I didn't highlight the whole thing in green. So the way this is going to go is there's the first part, which is kind of doing an experiment for yourself and then recording your data. And so this is empirical data, something that you observed while you were doing it yourself. And then the second part is theoretical data. So this is where we're going to rely on our understanding of the binomial distribution. So what we're going to say here is what should happen theoretically, hence theoretical data. So let's take it from the top. So in the first part of this project, you're going to see a few links. So we need 3 dice. If you don't have dice at home, then you can roll virtual dice. And so I've linked to a virtual dice roller. So you probably have to hit, you can either copy the link and paste it into your browser, or you can hit Control click. And that's going to take you to a random dice roller. And so you can say how many dice you want to roll. All right, so to start out, we want to roll 1 die, and this is going to be our lucky die. So I'm just going to say, okay, I want to roll 1, and then I'm going to roll the dice. All right, and I got a 2. So for me, that means that my lucky die is 2. And now with that, I want to kind of repeat the experiment, but now rolling 3 dice. So I can either click on these links here that will take me directly to the rolling 1 or rolling 3, or I can go back and set my form to 3 dice. All right. So I'm going to roll 3 dice. And what I want to do is I want to look how many times in these 3 rolls did I get a 2. So this is number 2 here. Roll 3 dice and record the number of dice that matches your roll in step 1. Well, I rolled a 2 in step 1, and then I rolled here for the second part, a 3, a 6, and a 5. So I got 0 2s, no 2s. All right. So what I want to do is I actually want to record all these things. So for my first one, I got a 3, a 6, and a 5, which means that how many 2s did I get? I got none. And then I'm going to do this again until I have 10 rolls. So if I roll again, then you'll see I got a 3, a 1, a 1. Again, I got no 2s. I can roll again. Okay, I'm feeling very unlucky. So a 3, a 6, and a 3. I still have no 2s. And so I'm going to do this all the way until I have all 10 filled out. All right, so I did some movie magic and I rolled a bunch of dice and I was incredibly unlucky. So now let's do our last roll. Okay, so great. So 6, 3, 3. So I got 0 dice. Okay, I'm not going to record this, but let's just see. Can I get a 2 in here? No. I hate this. All right. So now that I've rolled my dice, what I want to do, this is part of my empirical data. I want to record the frequency of all of my rolls. So my possible outcomes, since I'm rolling 3 dice, my possible outcomes for matching, I could have gotten 0 matches, 1 match, 2 matches, or 3 matches. So for 0 matches, how many times did I get 0 matches? So if I look at my third column here in this table, I can see that I got 0 matches 8 times. And then I got 1 match 2 times, and then I never got 2, and I never got 3. All right, so for relative frequency, since I rolled this 10 times, then I'm going to put everything over 10. So this is 8 over 10, 2 over 10, 0 over 10, 0 over 10. And I can convert these to decimals if I want. So this would just be 0, this would be 0, this would be 0.2, and then this would be 0.8. And so this actually gives me the empirical data for my probability based on my experiment. So the next thing I want to do with this is I want to create a histogram. So this kind of harkens back to the chapter 2 stuff. So let me open up an Excel so I can create a histogram. All right, so with Excel, what I can do is I can type in, actually, I'm just going to do X and then I'm going to do my frequency. You could do relative frequency if you want, it's totally up to you. So here my outcomes were 0, 1, 2, and 3. And my frequency was 8, 2, 0, 0. And so by highlighting this, I can go ahead and insert a chart. And I like to go to recommended charts because it gives me a little bit of a preview. And so I like this one, that seems to fit. And so now what I can do is I can go through in the way we have before, I can change my chart title. I want to make sure that I can decrease my gap width and make it kind of look nice and pretty so I can insert it into my Word document. All right, so I formatted my histogram. So all I'm going to do is select this, I'm going to copy it, and then I want to paste it into my Word document. So I can get rid of this guy and then hit Control V. And so now I have my histogram here. The next thing we want to do is we want to compute the mean for our frequency distribution. And so the way that we do this is we take X times the frequency. And we've done this before in chapter 2. So this is just going to be my X value times my frequency. And then I can fill that out. I also want to take my total frequency using the sum function. And so this will give you my total frequency, and then this will give me my sample mean. And so in order to compute the sample mean, all I need to do is take the sum of this, right? These values here. And then I want to divide it by my total frequency, which was 10. And so for me, I got 0.2 as X bar. There's another way to do this. I'll show you real quick. If instead of doing frequency, let's say that you did, okay, person, move that out of the way. Let's say instead of doing frequency, you did your probability. Then what you would have here is 0.8, 0.200. You could use this too. And then you would have your X times your probability. Drop that down, and then taking the sum of this X times your probability, that would also give you your sample mean. And so both are fine, both give you the same answer. All right, so the next thing we want to do is we want to compute the standard deviation for the frequency in step 1. And so because this is an experiment, this is just a sample, this is going to be a sample standard deviation. So in order to compute our sample standard deviation, we need to do it in the same way that we have in the past. So that means you need to do your deviations which is X minus the mean. So X minus your mean, and you need to keep your mean static. So you can do that by adding the dollar signs. And then we're going to drop this down. Then we need to square our deviations. So just taking this and squaring it, dropping that down. And then what we need to do is we need to take the sum of that. Then we need to divide by 1 less than the frequency. So divide it by 9. And then we're going to take the square root. And that's going to give us our sample standard deviation. All right, so here's our sum equals sum. Divide by 9, square root. And so our sample standard deviation should be 1.1, I'll just say 1.143. All right, and so the last thing I'd want to do here is I would want to share my link. So I would hit the share button at top. I would want to make sure that I've saved it to OneDrive. And so now I can copy my link, copy, and then I just want to paste it right in here. Right, okay, so now there's my link that I'm sharing. All right, so the next thing I want to do is now I want to get into the theoretical data. So that was me being super unlucky, right? I had all these bad rolls. I never got really any 2s, kind of sucked. But now I want to think about, all right, well, what's the probability distribution function? What should it be in theory, right? This is a binomial thing. We're rolling the dice 3 times. So we have 3 independent events. And I'm looking for the number of 2s. So because I am rolling the dice 3 times, that's my number of trials n. And because I'm looking for the number of 2s, then the probability of success is the probability of getting a 2. Well, the probability of getting a 2 is just 1 out of 6. So now I can look at this as a binomial distribution with 3 trials and a 1/6 for probability of success. This will allow me to fill out this table here. So if I use my Excel file, right? So I'm going to roll dice 3 times. I want to count the number of 2s that appear in the 3 rolls. That's my random variable. And so I'm rolling 10 times, and my probability of success is, just kidding, I'm rolling 3 times. My probability of success is 1/6. And so then when I do this, it'll automatically fill out all this stuff for me. And so I can actually take these values here, 0.5787, all the way down to 0.0046. Those go in this table here. And I can actually just copy this histogram and paste it directly into my project. So we also need to compute the mean and the standard deviation. Excel does that for us. So we have here the mean is 0.5, right? So I'm just taking this straight from my Excel document, and my standard deviation is 0.6455. Sure, that's fine. All right, so the last part is really up to you, the analysis. So we want to compare and contrast the empirical data. So again, that was the experiment that I rolled where I was horribly unlucky. And I want to compare that to the theoretical data, which is what we just did using the binomial distribution. So if it's different, why is it different? So what accounts for these differences, and what does X bar represent, and how is it different from mu, right? How is the sample mean going to be different from the theoretical mean? They're probably numerically different, but why are they numerically different? And you want to go through that kind of same process for the standard deviations. And then the bonus points here is if you can create a bar chart in Excel that shows both the theoretical data and the empirical data on the same axes, like an overlay. So that's extra credit. You're on your own for that one. You don't have to do it. You can still get 100% on this project without doing the bonus points. So now that I'm all done with that, I want to get a copy of my Word document and share it. So I've copied my link and now I'm ready to go back to mom, wherever she is. And now I can go into my chapter project 4.8. I can do my Word document here. And I also want to share my Excel document as well. So if I go back to my Excel document, the one that I actually use to compute this one, I can share that here. Copy link, copy that, share that here. And I can also share my one to my binomial as well. Right, and so all I would do is submit question and I'm all set. So notice that it gave me a 0 out of 1. Thanks a lot, mom. But that's only because I have to wait for it to be graded. So once it's graded, your grade will appear. Just because you have a 0 doesn't mean I didn't get it. So as long as you hit submit, you should be good to go. And if you get this red banner, it means that it accepted your submission and it's waiting for grading.